Addition and subtraction of fraction homework. We have two fractions here, 3 over x plus 2 over x. These are like fractions because they have the same denominator. So what we're going to do is we get to keep the denominator, which is x, and we're going to add our numerators, 3 plus 2. 3 plus 2 gives us 5. The final answer is 5 over x. Number 3. We have 5 6 minus 1 6. Notice again, we have like fractions, the same denominator. All we'll have to do is perform the arithmetic with the numerators. Keep this over 6. Now 5 minus 1 is 4, so we have 4 6. Our fraction is 4 6. However, all our fractions have to be reduced. So I'm going to break 4 down into the product of its primes, 2 times 2. I'm going to break 6 down as 2 times 3. 2's cancel, only one set. I'm left with a 2 over a 3. Final answer is 2/3. Number 5. Negative 3/8 minus 1/8. We're going to notice that, again, these are like fractions. I'm going to also point out that as I read this left to right, I start with a negative sign. So I'm going to write this as a negative 3 over my 8. I'm going to keep that negative sign with the numerator. Minus 1 over 8. I'm now going to take that negative 3 with the numerator and subtract it with 1. I perform my arithmetic in the numerator. Now be careful, because the arithmetic that we see here in our numerator is actually negative 3 plus a negative 1, because we can write subtraction as addition of a negative. And this is over 8. So now negative 3 plus 1 is negative 4. That's negative 4 over 8. I'm going to keep my subtraction sign here at the same level as my division sign. So I can reduce the fraction 4/8. Now 4/8, if I break 4 down, that's 2 times 2. 8 is written as 2 times 2 times 2. I'm breaking these numbers down into their prime factors. Cancel one set, second set of 2's. I'm left with a 2 in the denominator position. Don't forget we could put a 1 in the numerator. And our final answer is actually 1 negative 1/2. It's number 5. Number 7. We have 4/15 minus 7/15. These fractions are like. So I'm going to keep my denominator of 15. I'm going to subtract my numerators. 4 minus 7 is negative 3. I keep my subtraction sign at the same level, and I break down my numerator and denominator into their prime factorizations. Notice 3 is prime, however 15 can be written as 3 times 5. My 3 cancels. Nothing is left on top, so I put my 1. Final answer is negative 1 over that 5 is left, negative 1/5. This is number 7. Number 9, 12 over 25 minus negative 3 over 25. This is what we call the minus situation. 12 over 25 minus a negative 3 over 25 can be written as 12 over 25 plus 3 over 25. We have again the same denominators. (12) plus 3 over 25, and we'll get 15 over 25. We're going to break down 15 and 25 into their prime factorizations. Now, let's see. 15 can be written as 3 times 5. (25) is written as 5 times 5. So when I cancel, only a 5 goes away. I'm left with a 3 and a 5. Final answer is 3/5. Number 11. Negative 2 over 13 minus 5 over 13. I'm going to write this with my negative sign on top for that negative 2. And notice again, we have like fractions, the same denominator. So I can subtract negative 2 with 5, keep that over 13. I'm going to perform the arithmetic on top. The arithmetic can be written as negative 2 plus a negative 5 over 13. So I owe $2 and I owe 5. I owe 7. Keep your subtraction or your negative sign at the same level as your division sign. And notice that 7 is prime and 13 is prime, so they will not cancel. I'm done. Number 13. 5 over 12x plus 7 over 12x. They have the same denominators. So we have 5 plus 7 over 12x. 5 plus 7 is 12, so this is 12 over 12x. Now, if you are alert, you're going to notice that 12 and 12, these are the same numbers. I can cancel. I'm left with an x, but that x is in the denominator position. So I'm going to keep that x in the denominator position, and I put a 1 on top, because 12 can be written as 12 times 1, so your final answer is 1 over x. We're done. Number 15. 6 over 25x minus 11 over 25x. We have the same denominators. I'm going to subtract our numerators and keep this over the 25x denominator. Now 6 minus 11 on top here in our numerator position gives us a negative 5 over 25x. We're going to keep our negative sign at the same level as our division sign. And now we get to break down our numbers. But in this case, only the 25 here can be broken down. So we have negative 5 over 5 times 5 x. Five cancels. I'm left just with the 5x. Nothing is on top, so we put a 1. Final answer is going to be negative 1 over 5x. And we're done. Number 17. Negative 4/9 minus a negative 5/9. Notice we are in a minus situation. The opposite of a negative is a positive. So I can write this as negative 4/9 plus my 5/9. That negative sign here can be written at the same level, or place that negative sign with the 4, the numerator. So now we're going to notice that we have, like fractions, we have negative 4 plus 5 over 9. Now negative 4 plus 5 is positive 1. We're done. Number 19, 1/4 plus 2/3. Notice the following. 4 and 3 are not the same. These are unlike fractions. We're going to need our setup. Now, what we're going to have to do is determine the LCM of 4 and 3. Now, 4 and 3, the least common multiple is actually 12. So here, I want to point out that my LCM is the value 12. So let's go back and fill in these triangles and these squares in our setup. The LCM of 4 and 3 is 12. So my 12 goes down here and right here. Notice now I'm going to have like fractions because we have the same denominator. Now 4 times some number in my denominator here is going to be 12. That's going to be a 3. I'm going to put a 3 on top and bottom. 3 times some number in the next fraction gives us 12. That's going to be a 4 and a 4. So when I perform my arithmetic now, 1 times 3 is 3 for the first fraction, and 2 times 4 is 8 for the second fraction. So let's be clear here. A 3 gets multiplied to the top and the bottom. A 4 gets multiplied to the top and the bottom. Also that we can obtain an LCM in both cases of 12, or a denominator in both cases of 12. That is the LCM of 4 and 3. We can now add the numerators together, like we did before. 3 plus 8, and that's going to give us 11. So our final answer is 11/12. Notice 11 is prime, 12 is not. 12 can be written as 2 times 2 times 3, but this 2, second 2, and 3 do not cancel with your 11. So you're done. This fraction is simplified. I want to remark though, there is a way for us to determine the LCM of 4 and 3. There's a technique. We need to prime that divides both 4 and 3 with a 0 remainder, a prime number. 2 is prime, it divides the 4 with a 0 remainder. 2 divides 3, but the remainder is 1. It does not divide both. The next prime is 3. 3 divides 3 with a 0 remainder, but 3 doesn't divide 4 with a 0 remainder. The remainder is 1. So if we look for a prime that divides both, we find that there is no prime. The LCM will simply be the product here of 4 with 3, which gave us the 12. Number 21. Three twentieths minus 2/5. These denominators are not like. We're going to have to use our format. We're going to need to know what the LCM of 20 and 5 is. Give me a prime that goes into both of these numbers. You might say 5. 5 goes into 20 4 times with a 0 remainder. 5 goes into 5 1 time with a 0 remainder. We're going to repeat the process. Give me a prime that goes into both of these numbers. 2 goes into 4 with a 0 remainder, but 2 does not go into 1. There is no primes. What this means is if I multiply these numbers, 5 times 4 times 1, I find my LCM to be 20. 20 goes down here and here. "20 times what number gives us 20? 1 and 1. 5 times what number gives us 20? 4 and 4. To summarize, 1, 1, 4, and 4. Multiplying my numerators and my denominators here. We get 3 times 1, which is 3. 2 times 4, which is 8. If I do the arithmetic, 3 minus 8 over 20 is actually -5 over 20. I'm going to put my negative sign at the same level as my division sign, and I'm going to simplify. 5 can't be broken down. 20 can be. It could be written as 2 times 2 times 5. We're now going to cancel one of the 5's. 2's are left, a 1 is left on top. Your final answer is going to be -1 over 4. You're done. -23. -5 over 13 plus 1 over 26. Notice that my denominators are not the same. These fractions are unlike. We're going to have to go through our process. negative 5 on top with a 13 multiplied with some number on top and bottom plus 1 over 26 multiplied with some number on top and bottom. My LCM of 13 and 26 is 26. We're now going to have to check. 13 times 2 gives us 26, so there's a 2 on top and a 2 on bottom. Similarly, 26 times 1 is 26, so there's a 1 on top and a 1 on bottom. Negative 5 times 2 is negative 10. 1 times 1 is 1. Negative 10 plus 1 over 26. I get a negative 9 over 26. Put your division sign at the same level. And notice, 9, since we want to break down our fractions or reduce them to lowest terms, can be written as 3 times 3. 26 is actually 2 times 13. Notice that nothing cancels. This means we're done. Negative 9 over 26. Number 25. Again, just to point out that these fractions are not like. They are unlike. They have different denominators. So I'm going to have to go through my setup and determine the LCM of 8 and 4, and that's 8. Eight times 1 gives us 8, and 4 times 2 gives us 8. So 3 times 1 is 3, 1 times 2 is 2. We find 3 minus 2 over 8, which gives us 1/8. We're done. (27) Negative 4/7 minus 2/3. These fractions are unlike. They have different denominators. We're going to need the LCM of 7 and 3. And the LCM of 7 and 3 is 21. So we're going to have to write our setup here. LCM being 21. So now 7 times what number is 21? We find 7 times 4 is 21. 3 times 7 is 21. 4s are in the triangles, 7s are in the squares. So now negative 4 times 4 is a 16, or a negative 16. 7 times 2 is 14. Keep the negative sign here at the same level, or I should say put it with the 16. You got negative 16 over 21 minus 14 over 21. Negative 16 minus 14 over 21. Perform your arithmetic in your numerator. Negative 16 minus 14 is negative 30 over 21. We're going to have to simplify our fractions, meaning break 30 down, and that's 2 times 3 times 5. 21 is 3 times 7. So the 3 cancels, and that is it. Your final answer is going to be, if I keep track of everything, negative 10 over 7. And you're done. Number 27. (29) 3/5 minus a negative 1/2. Notice opposite of a negative. So we have 3/5 plus 1/2. These fractions are unlike. They have different denominators. We're going to have to go through our setup. We have to determine the LCM of 5 and 2. Now the LCM of 5 and 2 we're going to find is 10. So 5 times 2 is 10, and 2 times 5 is 10. So 3 times 2 gives us 6. 1 times 5 is 5. We're going to write this as 6 plus 5 over the 10. We're going to add our numerators. We get 11 over 10. And we're done. Number 31. We get negative 7 over 8 minus a negative 3/2. Minus the minus gives us a plus. Negative 7/8 plus 3/2. These fractions are unlike because they have different denominators. You have to go through our setup. The LCM of 8 and 2 we're going to find is 8. So let's find what goes in our triangles and our squares. 8 times 1 is 8, and 2 times 4 is 8. So we're going to get 7 and 12. Keep your negative sign here at the same level as your, apply it to the negative 7, or to the 7. And that way I could just do my arithmetic with my numerators. Meaning, take negative 7 and add it with 12. You end up with negative 7 plus 12 is 5. 5 over 8. Notice, 5 is prime in the numerator. The denominator has an 8. 8's not prime. We can write 8 as 2 times 2 times 2 as a product of its prime factors. Notice that 5 doesn't cancel with any of the 2's. You're done. We got 3 minus 4/5. A whole number minus a fraction. So you write your 3 as 3 over 1. And then notice we have, again, unlike fractions, the denominators are not the same. Three over 1 triangles, 4 over 5 squares. My LCM of 1 and 5 is 5. We have to determine what goes in our triangles and our squares. 1 times 5 is 5. 5 times 1 is 5. So a 5 goes in the triangles, a 1 goes in the squares. 3 times 5 is 15. 4 times 1 is 4. We now have to do our arithmetic. 5 minus 4 over 15, we find this is 11. Oops, not 15, but 5. 11 over 5. LCM of 1 and 5 is 5. Notice both of these numbers are prime and they do not cancel. This is number 33. Number 35. Negative 2 plus 1/5. We're going to write that negative 2 as a fraction. So it's negative 2 over 1. So I have negative 2 over 1 plus 1/5 again. These are unlike fractions. Unlike because they have different denominators. So I'm going to go through the setup. I'm going to need an LCM of 1 and 5. The LCM is 5. We have to determine what goes in our triangles and our squares. 1 times 5 is 5, and 5 times 1 is 5. So in the numerator for the first fraction, I get negative 10, and for the second fraction, I get 1 in the numerator. Keep the negative sign with the number on top. This negative sign is here. We can now perform our arithmetic. Negative 10 plus 1 is negative 9. Now, that negative sign is in the numerator position. I'm now going to write it at the same level as my division sign so I can actually simplify. Now notice, 9 is written as 3 times 3. The 5 down here is prime, and nothing will cancel. You are done. $37. 7/12 minus 1. We're going to put this over a 1, so we have two fractions. So we have 7 over 12 minus 1 over 1. These are unlike fractions because our denominators are different. So we need the LCM of 12 and 1, and it's a 12. Now 12 times 1 is 1. This is what goes in my triangles. And 1 times 12 is 12, and 12 goes in our squares. So that we now have 7 times 1, which is 7, and 1 times 12, which is 12. We can subtract 7 with 12 over 12. Notice we get negative 5 over 12. Put your negative sign here at the same level as your division sign. And see if you could break down and cancel. 12 can be written as 2 times 2 times 3, but it does not cancel with a 5. That means that this fraction is simplified. $39. 1/5 minus 1 over 15. Notice these are unlike fractions. We have to do our setup. Now we need the LCM of 5 and 15, and the LCM is 15. We're going to have to determine what to put in our triangles and our squares. 5 times 3 is 15. 3 goes in our triangles. 15 times 1 is 15. 1 goes in our squares. We end up with 3 and 1. Now, 3 minus 1 over 15 we find is 2 over 15. Notice 15 can be broken down as 3 times 5, and that does not cancel with the 2. We are done. Final answer is 2 over 15. (41) 4 over 13 minus negative 1 over 5. Minus the minus makes this a plus. 4 over 13 plus 1 over 5. We're going to have to do our setup. Triangle, triangle, square, square. We need the LCM of 13 and 5. The LCM of 13 and 5 is 65. We have to determine what goes in our triangles and our squares. 13 times 5 is 65, and 5 times 13 is 65. So, what this means is 4 times 5 is 20, and 1 times 13 is 13. 20 plus 13 over 65. I perform my arithmetic on top in the numerator position. 20 plus 13, and we get 33 over 65. Now notice, 33 can be broken down as 3 times 11. 65 is 5 times 13. We broke the numbers down into their primes, and nothing cancels. What that means is our fraction is simplified. We are done. (33 over 65). (43) negative 8/9 minus 1/3. We have different denominators. Our fractions are unlike. The negative sign we're going to put with our numerator. So we have negative 8 over 9, triangle, triangle, minus 1 over 3 with our square and our square. LCM of 9 and 3 is 9. 9 times 1 is 9, so 1 goes in our triangles. 3 times 3 is 9, so 3 goes in the squares. Negative 8 times 1 is negative 8. 1 times 3 is 3. Negative 8 minus 3 over 9, and we get negative 11 over 9. Now that negative sign in the numerator can be placed at the same level as our division sign. We do this so that we can simplify our fraction 11/9. Now 11 can't be broken down, but 9 can be as 3 times 3. Notice that 11 does not cancel with any of my 3's. The fraction is simplified. We are done. (45) 5/12 plus 1/4. Again, 12 and 4 are not the same. They are unlike. And I have to do my setup. The LCM of 12 and 4 is 12. 12 times 1 is 12, and 4 times 3 is 12. 5 times 1 is 5. 1 times 3 is 3. We're going to take our 5 plus our 3 over 12. We're going to add 5 and 3. 5 and 3 gives us 8. So this is 8 over 12. Every fraction needs to be reduced. So 8 is written as 2 times 2 times 2. 12 is 2 times 2 times 3. We can break them down into their primes. 2's cancel, 2's cancel. We're left with a 2 and a 3. Final answer is 2/3. We are done.